Given the two similar right triangles with a common angle theta, we will express these sides in terms of the trigonometric ratio of theta. The inner circle is the unit circle which has the radius 1, and the outer circle is a circle with radius r. Therefore, if we let x0 be a, y0 be b, x equals c, and y equals d, and the radius OQ has a length of r, where x0, y0 is the point on the unit circle, q, x, y is a point on the circle of radius r, where x0 is a, so the length AO is a, y0 is b, and so the length AP0 is b. X equals c, so the length OB is c, and y equals d, so the length BQ is d, and the radius of the outer circle is r, the radius of the inner circle is 1. Using the smaller triangle, keep in mind that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent, with the reciprocal of sine, cosine, and tangent are cosecant, secant, and cotangent, respectively. Sine of theta is therefore opposite is a p0, which is the vertical length y0 or b, over the hypotenuse is 1. Cosine of theta is the adjacent OA, which is x0 or a, over the hypotenuse 1. We are using the smaller triangle here. Tangent of theta is the opposite b over the adjacent, which is a. If we were to use the larger triangle, then sine of theta is BQ, which is y, but y is d, over OQ, which is the hypotenuse of the larger right triangle, which is r. Cosine of theta using the larger right triangle, the adjacent is OB, which is x, but x is c, over the hypotenuse, which is r. And tangent of theta is the opposite, which is d, over the adjacent OB, which is c. Now, to get the remaining trigonometric function, we just simply write the reciprocal. For cosecant, using the smaller triangle, cosecant of theta is 1 over b. Secant of theta is the reciprocal of cosine, which is 1 over a. And cotangent of theta is the reciprocal of tangent, which is a over b. Using the larger triangle, cosecant of theta is the reciprocal of sine theta, which is r over d. Secant of theta is r over c, and cotangent of theta is c over d. Note that although we have two circles, in this case, we did not use the circle to write the trigonometric ratios. We use the right triangles instead. But this demonstrates the relationship between the trigonometric ratio using the right triangle and the trigonometric function using the unit circle. The consequence is that before, we used the unit circle to define the trigonometric function, but with these, we don't need the circle to have a radius 1 to define the trigonometric functions. We can define the trigonometric function with any circle of radius r.